Okay, so once again, welcome to the second series of our seminar. I'm quite sure you've all spent time to observe the first series, and you might have gone through the content out there. It's a pleasure to have you here today. In the other series, being 3, 4, 5, they are now going to be problem specifics. So we shall put together problems in different domains, in different areas, with different scopes, and then we come together and begin to try our hands on and see how it works. I'm quite sure that everyone here have already had a chance to join us in the first series, which also means that everyone here have Matlab or Octave pre-installed, and everyone here also had a good internet to enjoy the 1 hour to 2 hour web series we are giving to you today. In the first series, a number of things happened there. Let's hold on to see what the second series have to offer us. As usual, I'm Justice Kwame Apati for University of Ghana with the Department of Computer Science. And I'm here to take you through the second phase of Matlab after you've enjoyed the first part of it, hoping that all things expected actually worked out the way you wanted it. Okay, so in today's section, you and I will want to look at some basic plotting, which couldn't end in the previous section, some scripts and functions, some decisions, then we go on to loops, and finally, how do you get to us? So as usual, the PowerPoint we have here is only a guide. That is why we have very few content on the slide. But you and I want to demonstrate right on the interface and see how things are moving and proceed from there. So in 3D plotting, immediately, it simply tells you that you have 3 axes to look at: the x-axis, the y-axis, and the z-axis. This means 3 points or 3 elements are required: the value of x, the value of y, and the value of z. This tuple defines the point in a 3D space. So all of these points put together on this grid, you cannot join them to form a shape, and that gives us a 3D object. There are other 3D objects that you and I want to also look at. We have the mesh as well as the surf. And you observe that to build or to render a 3D object, you need to actually have a 2D representation. An architect draws a 3D building for you, but all they are doing is to draw a 2D and then render it into a 3D by adding a height to it. And how then do you put together this 2D? This is where the mesh grid becomes important, to be able to render your mesh or your surf. So take note of that. And you and I will want to look at the mesh and surf by considering this equation, given the following point, and giving some discrete representation over here. So how then do we do that? And before then, you and I will want to look at the plot tree. How does it work? In our previous section or series, we came across the plot function and how to use it. In today's section, you and I will want to explore the plot tree, the mesh, and the surf. With the plot tree, we shall try to plot a spiral. And how then do we do that? As you can see, some form of a period is being formed over here. So immediately, sine comes to mind, cos also comes to mind. on a given t, and t being the time. So we shall plot on the axis, x-axis being cos of t, y-axis being sine of t, and the z-axis being the time itself, the time at which they fold in. This is what we want to plot using our Matlab. So let's proceed to observe what then happens over there. So we have our t to plot, and t is going to span from 0 to 10 pi. From 0 to 10 pi. And then the point of steps, or the steps we use, is going to be pi on 50. Pi on 50. That will be the step. In a previous series, immediately we know that we are building for ourselves a vector. If that's the case, we start with 0. And as we saw in the first series, we continue with a semicolon, followed by our step being pi on 50. Then we end on 10 pi, 10 times pi. Again, in the first series, we noted that if you don't want this to print out onto your screen, put a semicolon there and hit enter. Now let's observe in our memory the workspace. You observe that we have a t over there, and the t had 1 by 501, which means we have a vector of size 1 by 501. Okay, now we know what our t is. Let us now look at what our x will be. Our x is cos of t, so cos, which depends on t. And we are convinced that we are dealing with radians. As you can see, it's about pi. So we found ourselves in the radian as a measurement. So we suppress, hit enter, and we have 1 by 501 as well. And our final value, y, is equal to sine of t. Sine of t. Okay, so again, we suppress and proceed from there. So now we want to plot. So plot 3. Why? Because we need 3 things. The first being our x, the next being our y, and the next being our t. So we close the brackets and hit our enter. And here we are with the spiral being drawn for us. As you move your mouse around it, you see the various points coming out in there nicely. We can decide to proceed to give a color. For example, I want a red color with a dot line. I hit enter. As you can see, some dotted points are being drawn in a nice curve being shown to us. This is how to generate a 3D object if it's all about a tuple of 3 elements in them. Okay, so you proceed to look at how to plot a mesh as well as a self. And how then do we achieve that? And that's what you and I will now want to look into and proceed from there. Okay, so here we are. Let's go back to our diagram or our PowerPoint and observe again our function given to us. We are saying that we needed a C. Now, it's important to note how to type this in Matlab. So let's verify or analyze some few things over here for ourselves. And what do we see? We realize that this function had a C. The C is the value 0.5 we are seeing here. This is a scalar. In our first series, we explained to you a scalar, a vector, and a matrix. Then we have a sign here, and we have 2 pi here, and an A. The A is also a scalar. And then we have over here x and y. X and y. But x and y is rather a vector. So immediately you know for sure that the x here is going to be a dot power or a pairwise exponent or an element-wise exponent. Do not forget what happened in the first series. In the same way, the y here must span from -1 to 1. And they are saying they wanted 50 spaces. Immediately, what comes to mind? The lane space, which you saw in a previous series. So let's start. So we shall declare our variables being the A and the C first. When we are done, we shall declare our X and Y, 50 spaces from -1 to 1. So let's go back to the working table. So our A is equal to 3. We suppress. Our C, I can write all on the same line. Our C is 0.5 over here, suppress, hit enter. Our X is a lane space spanning from -1 to 1 with 50 cuts. So here is our X. What then do you observe? The value of X is 1 by 50 because of the value here. And the same thing must happen for our Y. So it's a waste of time for you to type Y equals lane space. Instead, just say Y equals X. This operation I've performed, be very careful if you are a Python person, because this process might fail you. Okay, so enter, and that's my Y as well. I told you earlier on that we cannot create a mesh or a surface using a plot tray. Instead, we use the mesh or the self. But the mesh and self requires that you build your component on the X and Y, after which we now elevate it with the Z. In the same way, you and I, we want to build our Z, but the Z we want to build must depend on the X and Y. So the first thing is to declare a new X, XX, a new Y, YY, and say mesh grid. And we are meshing and creating a grid using our X value and our Y value. Okay. Then we hit enter. What do you see? It creates for us a YY with 50 by 50 mesh and an XX with 50 by 50 mesh. It's important to note how this mesh grid actually works. To do so, let's come here and give you a few visuals over here. And then cross over here. What then do you see? You see that the point here and a point here and a point here and a point here creates a value for us. These values are the points you're looking for to plot the diagram on the Y. So what do you see? Over here, the X values are changing, but the Y value here remains the same. If I go this way, or if I observe with my eye this way, you realize that the Y is changing here, but the X remains the same. Okay, so this is the grid we are creating. Let's go in there to observe something small for ourselves. I'll do P is equal to 1, 3, 8. And then Q is equal to maybe 4, 6, 7. So PP and QQ, these are just variables. It's equal to mesh grid. And I'll open up this for us to look at what's happening, P and Q. Then I hit my enter. Let's observe what happens. This is how PP looks like. This is how QQ looks like. So this is what's going to happen. So here is our PP element. So this P will match this Q. This P will also match this second Q. this P will match the third key over here as a coordinate. So 1, 4, 1, 6, and 1, 7. This becomes 3, 4, 3, 6, and 3, 7. So then you observe, if these are x, you're creating this x value and repeating them all across. In the same way, we have the y value and repeating the y this way. So in column wise. And this is in row wise. This is what is happening behind the x and y to create the grid we are having over here. So now we know what the mesh grid is doing. Let's now compute our z on that mesh grid. So we start. Our z is equal to our c, which is known to us up here with a value of 0.5. Then the equation, we see a sign. So sign into bracket 2 pi, so 2 times pi times a, and all these are scalars, so we don't really care, times, now the main issue, so multiply by the square root SQRT, and SQRT understands matrices, vectors, and scalars. But we want to be able to create a Z which is the same as the mesh of of the X and Y. Okay, so we move on to type the one in here, X squared. This is where you have to be careful. You can't say X squared like this because your X, so in this case, is not X, but rather XX in the grid. So XX plus YY to the power 2. The danger here is that the YY here is actually a grid. The XX here is also a grid. So therefore, we can't do the square on it. What you are doing is square of the element within. So it becomes a dot. And here also becomes a dot as well. This is something you must pay attention to. So as I hit enter, I end up getting a Z, which is also 50 by 50. At this point, you and I can now plot our mesh or our self. Let's start with the mesh first, and let's compare the two graphs and see what happens. So I'll type mesh into brackets, then my XX, my YY, and my Z. Close my brackets, hit enter, and this is how our graph looks like. As to how to interpret this, it depends on your domain, your area, and what you are looking out for. So we shall not spend time with interpretation in series 2. In series 3, that's where you and I will look at practical examples where we come together, do problem solving, think through it, and develop that algorithm, that code for the given problem. They cannot interpret the graph along with the question or the challenge or the problem. Okay, now I'm going to plot a second graph, but I don't want this graph to vanish. So I'll open a new graph to do so. To open a new graph, just type figure, hit enter, and this is my second graph. And here I'll type self, then again, XX, YY, and a Z. Hit enter. What do you see? You realize that in a mesh, you see some kind of a net-like thing with the lines in there as a mesh, like a spongy stuff. But on the self, we have it being colored, we have it being fleshed out. All the holes in there are now filled with colors. They are the same thing, but one comes out much clearer than the other. As you can see, it forms some form of a cone in it, and it comes out that way. The interpretation will be left out to our third series. We hope you will not miss it, and that's where we shall look at real examples and proceed. Don't forget, today ends the introductory stages. After today, the next thing will be how do you apply all the things you've learned in these 4 hours from the first day or the first series to this series. So this is how to perform a 3D plot in Matlab. Okay, so you proceed from there. Of course, other things like the X label, the Y label, the Z label are still applicable over here. All those things are applicable. Okay, so we close it up and proceed to look at the next thing for today's series, which is scripts and functions. Scripts and functions. So let's observe what is happening here. As you might have seen in your Python sessions or in your C++ sessions, you can name them. Most often, you end up seeing a concept or a file or some kind of a structure that produces nothing and something that also returns a value. As far as Matlab is concerned, we aren't seeing things in that direction. Okay, so remember I told you earlier on in the first series that the moment I shut down my Matlab, I lose all these things I have. I have to start all over again. That's not fair to all of us. So how then do we document this so that we'll be able to reproduce this anytime we come back? To do so, we have to create a file and put in our content. But this content will return nothing to us. And that will serve as our scripts. Okay. So what then do you want to do? In Python, let's even come local. In Microsoft Word, we save our file into docx. In Excel, it is xlsx. In Python, it is py. In Matlab, it is m. It is m. And that talks about the extension in Matlab. So we shall put all the content we've done so far together into a file so that tomorrow we can open it and continue, so that next month we can continue from there. In our 5th series, we shall learn how to build an interface, a GUI, an interface, so that people who can't use Matlab can get an interface, play with it, and get the answers they are looking at for. So a small app in Matlab, we shall learn them as we proceed. So how do you create a script in the first place? There are several ways of doing that. When we are done, how do you run a script? Again, there are several ways of doing that. And finally, how do we check for an error? And this is one of the critical things why I like Matlab so much. And why I think in the industrial level is also highly used, especially in engineering. And most parts of Asia and the US make use of Matlab a lot. Okay, so let's start with how to create. As usual, I'll clear my interface, CLC, and clear my command, my workspace, CLEAR. So now I have a clean space for us to use. Let's now start. To create an M file, you can simply go to New Script, where my mouse is hovering, go there, click on New Script, and then it opens this editor window for you. Then you can now start typing your stuff. In this window, you shall see over here untitled as the name of the file, which you must change. Secondly, you see a small green color here that tells you that the code is clean. If you see red, it simply means there is a bug. If you see yellow, it simply means there is a warning. Warnings will run. So yellow will run, green will also run, but red will not run. So red is something you must address. Now, I don't prefer to create a file by this approach, or because in quotes, I feel lazy to change or to save this file to something else. So once I type something in and I save, I'm forced to now go and click on all those stuff. So I don't prefer this approach. So I'll cancel and I'll show you the other approach I prefer. Don't save. Just type edit, then the name of the file, justice.m. My file name is called justice.m. Once I hit enter, automatically it creates a file for me if and only if it does not exist. As you can see, this is my directory, IW research. In my IW research, there's no file called justice.m. If there is, then edit will only open the file for you. So I hit enter, and as you can see, I have a file already called justice. So it ended up opening a file already existing here. So when you scroll through, you should see maybe justice somewhere. I'm not quite sure why my eye cannot see it in the IW. So most likely it's mixed up somewhere in there. It's mixed up somewhere in there. Yeah, but all it means is that in my directory, there is a file called justice.m already. So just close it and create a new one, maybe series2.m, edit, series2.m. Let's hope that series2 also does not exist. So enter. So yes, it does not exist. So yes, create it. As you can see, we don't see it as untitled, but instead series 2. Series 2. So this is where I'm going to type all my stuff in. At this point, it's important to note that whilst typing, try and apply all the rules we know in getting a clean code written. This is your code we understand. In the future, this code, you forget it. So therefore, it's always advisable as a good practice to always document your code by putting in relevant comments. So I'll just put in my %sign and say, this is just something. This is our second series as a comment. So here, I'll now start. I prefer to always section my codes. To do so, use double % and a space. As you can see, a line is being shown here. So I'll just put something like this and say data declaration. I prefer to always section my code so that it's easier for me to trace whatever I'm doing. So here, as you can see, we have two data or two parameters to declare, and that is my A being my 3, and then as you can see, once I do so, the red color comes up and say, hey, there's a warning for you. Do you want me to fix it? I'll say, yes, fix it. And what's the warning? I have failed to suppress my value, so fix it. Then it's gone. Okay, always read. Sometimes the fix provided is wrong. So I have my A and I have my C to declare that as well. And my C was 0.5. So I suppress again. Okay, that's fine. Yeah. Okay, so you continue. So 0.5, then I continue. So here I've declared. So the next thing is to now create my expressions. So again, I section in there and say, just put something there. Just put something there. I'll just say X, 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 and we just continue. So here I declare my X. I may decide to come here and then say my X is equal to the linspace the linspace into brackets, and here my values are 0 to 10 times 10, so it was minus 1 to 1 with 50 steps. And then I continue y equals x. So here I am, suppress. So here I build my mesh grid, square bracket, comma, square bracket. Don't forget, just as we saw in Python, I want to produce two outcomes from mesh grid. So I do y all together and then produce the answer into it. We shall see how to build some of these things for ourselves. As you can see, a red button is shown here to tell us that, hey, we are in error. So mesh grid, then to bracket my x, my y. I suppress. Then I declare my zz maybe to be my c times, let's go back to the equation, my c times sine 2 pi a sine 2 pi a 2 pi a 2 pi a followed by my sqrt. Then I need my xx dot power 2 plus my yy dot power 2. This now ends my expression. So here, I will now put in another one that says plot them, plot self and mesh. Plot self and mesh. So here, I have my mesh, and here, xx, yy, and zz. I suppress, and I realize that if I don't create a new figure window, then this will replace the other one. The self will replace this one. So I'll say figure, and then I proceed on the same line. It's possible, self, and then as I type, it gives me some intelligence how to add on. So xx, yy, and zz. So now I am done, which means we are done with the first part here that talks about creating a script. So now my script is created. Anytime I have a problem to solve, I always script them first. When I'm done, I convert it into a function so that other people can use it. Okay, and we shall see when to do that as well. So how then do we run? There are several ways of running. Save it, come here. Don't forget, there's one more thing I failed to add. Always make sure you have a clean interface. So CLC and CLEAR. Just put these things together for yourself, and then you are good to go. Okay, so I have my clear. If you start doing graphs, there's one more to add to it if you want us to add, which is called the close or hidden. The close or hidden. Okay, the close or hidden will ensure that all graphs that I have behind the scene are also closed. That's what it also do for us. Okay, so close or hidden. So I tap, here we are. Okay, can also do clear or that's a much deeper clearer, or a much deeper clearing. So I have this, then I can now run. To run, there are several ways to run. As you can see, this script does not demand for an input from me. So just type series 2. Series 2. This is not a function, so I can't say brackets. So I hit enter, and then here we are. The first graph, second one behind it. So now, if accidentally my computer shuts down, I don't really care. Why? Because this code is already available to me to use. This is what you must pay attention to. And this is why it's important to always script and don't be typing here. This is just one way of running my code. Anytime I open my editor window, I see this button also there, which is play. Click on play, and the same thing will also happen. So here we are. Here we are with our content. Okay, so you proceed. Now, I have now explained to you how to create, how to run. But argument here is, how then do you proceed from here? How do you explore if there is a bug in our code? Okay, so we shall explain to you how to debug. Imagine I plot my graph and I see something very strange. One thing you must pay attention to is if I have an error like this, and I run this code, for example, and tells me there's an error, I prefer this type of error. It says, I don't know what Z is. This is where the error is, where the ampersand symbol is. So I go there and look for the error and fix it. The dangerous one I hate is the one that tells you nothing. It tells you nothing, but the answer you are getting is wrong. Okay, so I fix. What if the answer I'm getting is not what Matlab gives to me? So come here and click on the line you want to debug. So click over there, and then you now see an arrow. You may not see an arrow depending on your version. In those days, it's a small ash circle. But the new version is a green highlight. Once you do that, immediately you see a K in your prompt. A K in your prompt. Okay. Let me put a bit out for you to see. A K in the prompt. That tells you we are in the debug mode. Once you are in the debug mode, then you see all this being activated. Step and continue. I don't do continue. Sorry, unless I'm convinced that that part of the code is going to work. So I put the green color here, then I'll do a step. I'll do a step. Okay, so in my step, click on it. And now there are two more things to explain to you. We have step in and step out. I do a step. The step will only take me through this interface. Next line, next line, next line. The step in will take me into the function itself. I can't do step in here because it's a variable assigned to a scalar. But I can do a step in here, which will take me into linspace and see how linspace work. Only do step in into your own built-in function. Don't do step in into Matlab function because you may commit an error of touching something wrongly, and that will require that you have to install Matlab all over again. So that's very dangerous. And two, I prefer the step in also for some of the Matlab libraries because, take for example, linspace doesn't do what I want. So I'll open linspace, copy the code, duplicate it, and change the name into my name, and do all the changes over there and proceed from there. Okay, if I move into someone's file, I click on step out, and to bring me back to my main interface. If I think I've found the error, I'll click on stop. This is how the debug mode works. And this is a very useful tool. You will never regret using it.
Hello, sir. Can you hear me?
I can hear you.
Please, I didn't see what you pressed to enter the debug mode. Could you please go back for me?
Okay, that's fine. So what I did was just bring your mouse, be in your editor mode, bring your mouse. In my case, you see something appearing here, my line 5. Look at my line 5. Something's appearing over there. Click on it, or click on number 5 itself to put the color over there. If I put a color here, you will not see this line showing in line 2. Line 2 says run and stop. But line 5 stays stop. So look at the message over there, stop execution at line 5. So click on the number itself or click on the play button close to the number you want to run. Okay. I hope you're okay. If okay, a thumbs up. If not, feel free, raise your hand and I'll call you up again to continue. Thank you, thank you, thank you. So now I do a step. As I step, it takes me to line 5. So I put my step again, then put the mouse on the A. You see telling you what A contains. Again, this is why I love Matlab so much. Click again on step to 5. Click on X. I expect 50 by 50. Imagine I'm getting 50 by 51. Put your mouse on it. It tells you the numbers behind the scene. These are the numbers over there. The first 15 or the first 10 of them. So I can even scroll through and observe if what I'm getting or what I'm anticipating is what I needed. So in programming, we start small and we scale. Start small and scale. So I start something small. Is it working the way I wanted it? Then I scale. So take note of that as well. So again, I step. Now, I am going to do a step in to see what I'm talking about. The step in will open meshgrade.m, that file for me. So step in, what do we see? Meshgrade.m. So it takes me through all the various things. I don't want to risk to look at the content over here because I may make a mistake and it will haunt me forever. So I'll just say, hey, this is not my code, so step out. So let's go and look at what happened if I do step in. This is what in your programming class, fundamentals, they talk to you about the namespace. The namespaces. This is my main space. What do you see? Look at the arrow. It's now faded out and it's now green over here. Once I do step out, it takes me back to where I ended. So step out, I come back to line 11 again. Then I do my step again. If I click on continue to just run through, just like play, just like play. And I don't do that. But I'll tell you when I do continue. So again, step, step. My first diagram is out. Close it. Step again. Second one is out. So again, I close it. Now observe, once I am done, the arrow is now showing down to say that I'm going to exit. I'm going to exit. Once I click on OK step, it will now go out and then the K will vanish from my command window. Let me now tell you when I use continued. I'll click on play again and then to stop at line 5, my debug mode. Then I know that all these guys will work. So I'll just put a new debug here, line 12. And I'll just say continue. I don't want to know what's happening between line 5 to 11. Continue. So as you can see, it never stepped. It just ran through to line 12. Then I cannot investigate what's happening over here and proceed from there. This is how it all works. Once I think I found the problem, click on stop, and then the green debug will now leave. This is how interesting it is to look out for your bugs. And again, this is useful if the error you are getting is unexplainable. You just can't tell what is causing the problem. It's good to get an error in the command window, but if that fails you, then the debug becomes important to know what is happening. As the series continues, we shall learn the profiler, analyzer, and the rest. If you got a code and the code is too expensive, it runs for 10 days, the code is still running. You can't tell what's happening. There's something in there taking all the resources. Then we do a profiler, analyze, and then proceed from there. A code for reuse, refactor. How do we do it? These are things as the series progresses. we'll be looking at as well. Okay, so now we know how to perform all these actions. Now the next thing is a function. Why will one want to do a function? The idea is that you and I think that our A and C will always remain 3 and 0.5. So we want to avoid that. What if Osman says I want 4 and 1? What if Abdul says I want 7 and 8? What if Asantua says I want 3 and 21? Then don't forget, as developers, we don't write code for ourselves. We write code for others to use. So you cannot be rigid in your thinking. One may say that, okay, what if I ask the end user to request for the inputs? No problem, that's fine. And how do we do that? So I'll come to line 5, still in script, and say inputs into bracket, enter the value of A, or the value for A. Then I'll throw this guy off, and I will now come here and say input. This means I need an input from the end user through the keyboard. Enter the value for C. So I run this code, take all the debugger, clear all the debugger here. So I'll clear this guy and clear that guy as well. And then just click on run. If I click on run, the code will not go. The code will demand for an input from me. My A was 3, and my C was 0.5. It demands an input from me. Hit enter, it gives me the graph. So now, Osman, Abdul, and Asantua can now pick this code and then put in their value and run it. But what if I'm running a very big code, a very large code, and it's going to run for the next 10 hours? I have to sleep. There's no way I can get up, come and enter this, go and sleep, and proceed. Instead, it's now important to convert your script into a function and make them reusable for others to also use. So, how do you convert a script to a function? First question, ask yourself, what are the inputs you think end users will provide? And what are the things you think end users have no control over? As you can see, the end users should have control over A and C. So comment it out. Comment it out. And now go up and define a function. And how do you define a function? In Python is def. In Matlab is function, space, followed by, do you want to give an output? The answer is no, because the outputs here are graphs. They are not values. So I will not provide an output variable. So just go ahead. The next thing to pay attention to in Matlab is, if you are creating a script, any name is possible. But if you are creating a function, the name of your function must be equal to the name of your file. So here, series, into bracket, just to convince you, look at mesh grade. The mesh grade here is the same as its name. This is what Matlab demands for anyway, so you cannot go otherwise. Okay, here they produce XYZ, but we are producing nothing, just graphs. Now my input, they are A and C. A and C. So here, I've converted this into a function. If I run this code, unfortunately, it will not go because it have no idea what A and C are about. So I have to come here and say series to into brackets. Once I say into brackets, as you can see, it can identify my function now and it says, hey, I've seen a function called series2. That function demands A and C. What do you want for A? I want 3. What do you want for C? 0.5. So enter. Something is missing somewhere. Reference, oh, good. So whatever I enter for A and C, this guy cleared it. So you have to clear it. Let's see if it allows us. Of course, no. So let's just clear it and then proceed. Okay. Because the A and C we need has already been cleared by the function. So you can have access to it. So we go up here, hit enter, and here we are. Here we are. Okay. This is how to build a function for ourselves. What do you see? You see the color here. That tells us that, hey, there's something I need from you. The name should be series 2. Now the error is gone. Okay. Now, what then do you observe? You observe that I type series 2, not series, but the code still run. However, there's a warning that tells me that the name of my function does not connect with my name. Doesn't connect with my name. So after correcting that, it becomes green and says that now everything about you is clean. So now I'm happy. I'm glad that my function is very clean. This is how we build the function. What if I want to produce an output? I want to know how my Z looks like. This is going to be a very, let's do it in a more nice way. But before then, let me take you through something called the docstring. The docstring. At this point, remember that we have 1001 functions in Matlab. I don't know it all. I only know the ones I need in my field because Matlab is meant for bioinformatics, informatician, for biologists, for aerospace engineers, for you can mention them, mechanical engineers, anybody can use Matlab according to what they need. I need them for computer science alone and mathematics, so I stay within what I need. I have no idea about your career, so you may also need it for something else. Is it machine learning? Is it deep learning? You can mention them. Those are the things that you will need. So you have to now learn and know what are the things you need. So I want to know if a function is an inbuilt function or not. For example, square root. I'll just type help, SQRT, hit enter. The moment I see something like this, it tells me that, hey, this is a function MATLAB already have. Just use it. And how do we use it? The syntax. It says square root of x. The input is, so how do we build something like this for ourselves? How do you build something like this for ourselves? They are being built at this level. So right after a function, type out your comment. This is a function that plots, self and mesh. It requires, so another comment, it requires an input for A and C. Then you explain what A and C is in context. Then next is this how to use it. Usage. Series into bracket, series 2 into bracket, 2, 0.5. So you must give a detailed usage for this. When I save, I'll come here and type help series 2. And what do you see? That's what I typed up here. This is a function that plots self and mesh. It requires an input for A and C. Usage is series 2 into bracket 2, 0.5. Now your question.
Say the name of the function, must it be the name of like the script, or you can change the name?
Thank you. The name of the function must always be equal to the name of the file if you are doing functions. But if you are doing script, we don't care about the name. It can be any name. But for functions, the name of the function must be equal to the name of the file. Okay, if you're okay, time's up. If not, feel free, ask again, and then we are good to go. Thank you. Thank you. Okay, so therefore, we'll now move on to looking at decisions. Decisions. This is where we need intelligence. This is where we need problem-solving skills. This is where we need analytical concepts to be able to proceed. The whole programming concept, whether MATLAB, Python, R, C++, Java, JavaScript, name them. The logic lies within decisions and loops. Decisions and loops. And our series 3, which promise to be more of practice or practicals, we'll be seeing some of these things and we're asking ourselves questions. Why do you think this way and not that way? Why that way and not this way? And proceed from there as well. And see what GPT wants to tell us and see which of them really makes sense to us. The next few minutes is what we want to look at. Decisions. Decisions. Okay. In doing so, you and I need to understand some few things about operators. The less than equal to, greater than equal to. We have the not equal to. This is what we do in not equal to. In some language, it's not equal to, whichever way. All these are relational operators. And all operators which are relational returns a Boolean, true or false. In MATLAB, true is 1, false is 0. Logical connects more than one relational operator if 2 is more than 1 and 1 is greater than 2. Then do this. This operator here is a logical operator, and there are 3 of them: the AND, the OR, and the NOT. The AND and the NOT are binary in nature, which means it needs 2 things to work. The NOT in nature is unary operator, which means it doesn't need any 2 things to work, just one thing. If not true, is false. If not false, is true. Okay, now how then does MATLAB performs operation with this concept? Let's try a few things and see what happens. Okay, so I'll click my interface and I'll close also my editor and type here 2 greater than 1. If it is true, it gives me 1, logical 1. The reverse, less than this, it gives me 0. It gives me 0. Okay, so if 2 greater than 1 and 4 greater than 3, it tells me yes, 2 is more than 1 and at the same time 4 is more than 3. Now all know that if 1 is false under AND, it will fail us. But under OR is bad. OR is bad. So some do 1 bar, some do 2 bar. The answers are always the same. So I do this and then it gives me a 1. It gives me a 1, which means this is true, but this is false. So one of them is true, that becomes true. These are things we play with. Okay, so not, not 2 greater than 1 or 4 less than 3. The answer we got here was 1. So we expect a 0 at the end of the day. So here we are 0. So if not true, then you are false. These are things we need to understand decisions, because in decisions we ask questions. So it's called a branching statement. If this is not true, then do this. If that's not true, then do that. If you see this, then do this. So there are always an action you must take based on a trigger. Those triggers are conditions. Those conditions are evaluated using logicals and relationals. Okay, so we proceed to looking at that. Now we know how the input looks like. Okay, let's proceed to look at another thing. What if they are vectors? x equals the following 153 is one vector. Let me just clear the interface first for the sake of my recording. And let y be equal to the following 028, 028. These are two different vectors of the same size. So x less than y. X less than y. If I hit enter, I get 001. So x over here is less than y. That's false. X less than y, that's false. X less than y, this is true. So 001. 001. Okay, now I want to execute a task only when all the outputs are the same. Then in this case, this will not work for me. So you must know what you want to do as well. Okay, so now we know how Matlab outputs the operation. The next thing is the difference between this and that. This is a test of equality, but this is an assignment. So x equals, say, square bracket 257. This is an equality. This is an assignment, sorry. So I want to know if x and y are the same. So x equals y. This is a comparison, not an assignment. Hit enter, it says none of them are the same, 0. X is 2, y is 0. X is 5, y is 2. X is 7, y is 8. They are not the same. That's the meaning of the element over here. So you must know when to use them and how to use them as well. Okay, these are very key things you have to pay attention to. So we now look at the first statement of our if. So here we have the if end structure. We have I've already explained to you the input already, the input function that demands an information from the end user. What I have not done is which displays an information to your screen. Okay, so the if end structure, the if else end structure, the if else if end structure. When you go to the market and you see orange, buy, period. So you go there and there's no orange, you don't call mom and dad and ask, oh, should I buy this also? The question is when you go there, or the instruction is when you go there and there's orange, buy. So if there's no orange, you come back home. When you go to the market and there's orange, buy. Otherwise, buy pawpaw. So you don't call home and ask, there's no mango. Should I buy pawpaw? No. The rule says when you go there and there's mango, buy. Otherwise, buy this. So you can only buy pawpaw when the mango is not there. You cannot jump. You are going to the market. You saw one woman crying pawpaw. Then tell yourself that, oh, mom says otherwise pawpaw. But you have not checked if there is mango yet. So please, an if construct are procedural. It asks the first one. If not, next one. If not, next one. So if end, are you false? If you are false, exit. If you are true, act. If else, are you false? Yes, go to the else. Are you false? No, do the if. The last one is the if else, if else. Are you false? Yes, go to the else if. Are you false? Else if. Are you false? So the else only works when all are false. The else only works when all is false. So this is under if, which means we must always define a condition that we want to use before it will work. Let's now begin to look at what is going to happen. Okay, so I'll clear my page. How do you write an if statement in Matlab? Just say if, then pass in your expression. This is going to be much work for me, so I'll just say edit series 3.m. So I'll create it over here, and here I'll just type, I want an input from my user. Enter a value of your choice. Then I pass the value to x. So if that x is less than 21, this is a condition. Now, in Python, you are forced to put semicolon. In Matlab, we don't do semicolon, just hit enter and pass out your argument. Display, oh, why am I spelling display wrongly? Display, we found you. We found you. Oh, this, not display, this. We found you. Okay. This is an if statement. Don't do any other thing, so end. Once I do an end, anything inside the if block here is considered one thing, and they're all reporting under the if. Now I run this code, and then it's asking for a value. I type 23. Because there's no else, it's as if nothing happened. As you can see, nothing happened. But the code actually ran, just that there's no else condition. Let me try again. Series 3, put in 4. 4 is less than 21. So it tells me we found you. We found you. So always never use an if without an else, especially if you're reporting an issue to your end users. Of course, I can do if without an else, if and only if I've declared a predefined value somewhere. But if I want to tell people and have a default, get a default, then always make sure there is an else statement. So here is our else statement. The else is found after the if. So else, don't forget, an else does not demand for a condition. So this, we missed you. We missed you. So we run, and then it says enter a value, 23. So now it says, oh, we missed you. So this is what is the best way to go. Okay. So what if I have another condition? For example, we are designing something for our grade book. If you are this, then display A. So if the value I have is less than, okay, let's go in, is greater than, if x is greater than or equal to 80, this is an A for me, but it doesn't end there. So here I have A and F, otherwise F. If I run this code, then apart from the A student, any other person is seen as an F. 80, 80, A. Any other number, 78, it says F. That's very unfair. So you come here, else if x is greater than, I'm not quite sure about the system in memory. So A is greater than or equal to, say, 70. Over here, it depends on how you want to do it and the hierarchy you want to do. I don't want to waste time to say and at the same time x is found less than or equal to less than 80. This is a waste of time because if you are really 80, this guy will trap you. So this is where the problem solving skills comes in. And that's what you and I will be doing in series 3. I don't know when, but I know very soon. So here we are with a B. So I run this code and then I enter something for B, 78. I get my B coming out nicely. So this is how we use the if, else if, and else condition. And again, the usage of all these things depends on the problem at hand. For now, we are only giving you information, knowledge to keep. And then in our next session, the third one, where we no more be doing all this again, but rather how to reason to a problem and address that problem along the line. Okay, so now we know how to use the if conditions to make a decision. Don't forget, anytime you see a piecewise function, it's also an if condition over there. And what are piecewise functions? X is equal to 1 if and only if x is greater than 2. Otherwise, this means all numbers less than 2 should be given 0. This is an if statement. An if statement. Okay. We then proceed to the loops. I want to do this again and again and again and again, the same thing over and over and over and over. A common thing is summation, which results in maybe a series. So I have a vector 4, 2, 5, 8. I want to add them. So it becomes 4 plus 2 plus 5 plus 8. Now the danger here among summation is that if you are doing sum, you get something in your head which you add 0 to, that number is always 0. So before you can do summation, you must define for yourself a variable called 0, and then you can add on to that value to say that x plus x, 0, x equals x plus our new number here in our sum value, our sum of I. How do you do this? You and I know for sure that we shall be doing summation. Let's call this guy P. Summation P of I running from 1 to 4. We are saying go and look for P1 plus P2 plus P3 plus P4. P1 is 4. Matlab is a 1 index. It's a 1 index, not 0 index. Okay. So, and we saw how to do substrings or sub arrays in our series 1. If I want 4, I'll just say P into bracket 1. If I want to P into bracket 2. If I want a number 8, P into bracket 4. So there's a virtual value somewhere called P0, and the value is 0. So P0 plus P1 plus P2, and this is where summation or the loop becomes important. There are two types of loop, the for loop and the while loop. The for loop is useful when you have a start and an end. You know when to start at 1, end at 4. This is a for loop. A while loop is used when the start is known, but the end is not explicitly known. That's the word. Not explicitly known, but the end is known based on a condition. So I'm saying look for the value until you meet this condition. Keep on searching until your eye is exhaustive. So how then do you write this in Matlab? And that's what you and I want to look at. So I've explained to you the if and the while. The use for, the while, and the for, and when. Use this when the start is known, but the end is based on the condition. Use this when the start and the end are all known. Here's an example I've given to you. And this is something you also want to do. So we'll do this one first, do this one next, and then proceed from there. So let's start. I'm going to suppress all these guys, comment them out, and then say that I have P to be a vector. That vector is 4, 2, 8, 9. Again, this is a vector you can have control over. So you can just build for yourself a function and proceed from there. So I want to do a summation. So SS is equal to 0. Keep it for me. Now for I is equal to P is equal to P. This means that don't forget the for loop is written as for I equals list or vector. Perform something here and end and end. But for a while loop, it is while a condition, then something here, end. So how do you build this vector here? I've taught you several ways. One is to 5, if the order is known. If the order is not known, like this, for example, it is 4, 2, 5, 8. They're not known. So this is how come I just place in the P. So here we are with the P, and I want to be adding on to the S. SS equals XS plus I, and I becomes the P value. So we now proceed to say end. But I want my end user to know the value of S. Since it's a script, I'll just say this SS. Unfortunately, this only allows a string. But what I have here is not a string, it's a number. So we do what we call type casting. Typecasting. This is a number, and I want the number to become a string. So just say num, which is a number, to str, string, str. So to now convert the number into a string for me. Let's run and see what happened. The answer is 23. 23, as you can see here. Let me just clear my interface and rerun again. 23. Now there is a function in Matlab called sum. Just say sum. Let's check if our P is available to us. Okay, so P is 4289. So just say sum of P. Now let's compare the answers. 23, 23. So now we are good to go. This is how to enrich your knowledge on how to program some of these things. Another person may say, no, this is how I want to code it. Start from 1, end at the length of P. Is it length of length? Help length. Okay, so it's other length. Okay, we don't even have length per se. So let me just say size of. So size, and then how many rows? So how many columns? So 2 columns over here. Okay, so the size of P, comma 2 is this. I'm sure it should be a length as well. Length of P. Yeah, so length of P is the same thing. The same thing. Okay. So size of P, comma 2. Then here we are going through I. So I is 1, 2, 3, 4. 1, 2, 3, 4. But the elements here are 4, 2, 8, 9. So we count P into bracket I. So take P, go to the first element and add, second add in that manner. So let us now look at what happens. I'm going to clear my interface and call this guy, clear again and call my series 3. The same answer is being produced. So this is where critical thinking and problem-solving skills becomes important to know which of them to use at what point to use it. Okay. Let's now look at something else to use while. While. I am going to tell users to give me values, and then if they give me a certain value, I will now stop. So I'll say declare SS to be 0. Take in information from users. So while our inputs, our first input X is equal to input, enter a number, less than, less than 20. So here we say if x is greater than 20 or equal to 20, then you have to stop. So we continue. Then add the value of x you have gotten, ss equals ss plus the x you got. And go ahead and ask again. Go ahead and ask again the new value of x. Here we are, and then end. So here, the only way I can stop this loop from running is when I enter a value 20 or more. So I don't know when you enter your 20 or more, but I know that when you enter it, I'll stop. So I run, save run, enter. Enter a value, or I shall put a space over here. It's not too nice. So space here, just to give the person the chance to know that this is where to type. So I save again, Control C. Yeah, so I enter again. Here I am. Enter a value less than 20, so 3. So it keep on adding. I forgot one more thing to display my final output when I'm done. This num to string of x. So now I stop, Control C to stop, and then I run my code again. So I clear my interface, run again. It demands a value, 3, enter. So, oh, there's something wrong somewhere. Oh, the condition is demanding for something rather more. Okay. So, if x is less than 20, less or equal to 20, then enter the value here and demand for the next information here as well. And a new input must come out. So that's the error I committed. So I enter, then 3. 3 is less than 20. It asks again. It asks again. It asks again. It asks again. Keep on asking again. Asking. So now I entered nothing. It has stopped. Once that's stopped, we expected an answer to come out, but it seems that this failed us due to an error in there. So again, it's where the debug becomes important. So keep on entering value. Now let me now enter 22. So here we are. So I did not take care of spaces. So I enter a space here and the code crashed. This is where the critical thinking, the problem solving skills comes in and proceed from there as well. So here the X came out, not the SS. So I come here and say SS. Run again. Sorry. So I clear. I run again. So I enter my values and then 22. It tells me the answer is 33. This is how the while loop works. It sums 3 plus 4 plus 5 plus 6 plus 7 plus 4 plus 4. Then this 22 never joins because it is a sentinel that stops our code from running. Okay. So we can equally now program something like this. Okay. So all too soon, we have come to the end of the journey, and you'll be wondering, in series 1 and 2, what is next? What can I do next for myself? How can I learn after this section? Because you've been told that series 2 ends the session of the basics. Series 3 begins the real implementations. The other series may not interest you unless that's where you want to go. Machine learning, data science, deep learning, mention them, differential equations, modeling, all of those things we shall see how to do them. So these are special sessions, and it demands that your basics are very good, as well as the domain knowledge is also very good to be able to understand. The beauty here is that you don't have to program everything that comes to mind. There are several repos out there to help you. One of the repos is a GitHub, but I don't do GitHub when it comes to Matlab. I do GitHub when it comes to Python. So the repo for Matlab is found as follows. Go online, click on one of these links, either this or this, one of them. It's called a MathWork. Create an account over this, a free account. When you are done, it exposes you to millions and billions of community codes, which have been certified by Matlab itself. So Matlab over the years, they'll look at the ones that they think they're convinced, then they'll adapt it into the main Matlab library. The ones they're not too sure of, they'll go through it. Maybe your code only works for this section, but not for this section. So your code remains there for all of us to come and use. Then we use it. This is where I want to see people who have subscribed to be here to end up one day. Just like for Python, when you are done, many must be able to do pip install to install your packages. So here, I want to see you one day putting your code on MathWork, which have been approved by MathWork, and the whole world can now download and use it. This is where we want to see you, hopefully. Okay, so feel free, get an account, and then start looking at some of the codes out there. Just search online, how do you do this? MATLAB code for doing so and so. MATLAB code for doing A, B, C, D. MATLAB code for machine learning. MATLAB code for this. Then it will load. The first one is always the MathWork. Click on it, but no account, you can't download. You can't download. So get an account and download it. Try them and see how they work. So numerical methods, you go online, MATLAB code for doing Gaussian elimination without pivoting. MATLAB code for doing Gauss Jordan. You download, you use it, you continue. Okay, so as usual, feel free, let's connect. See you on LinkedIn, see you on YouTube, see you on Twitter, see you on Instagram. But again, we have more presence on LinkedIn. Come out there, ask your questions, put all your DM there. We'll get back to you and respond. And the video is made available on YouTube, and the link will be shared with you to go and watch it as well. Not all videos are made public, so when you go there with the link, you always will see it. Moving to Twitter, let's chat, let's talk, but again, we have less presence over there, but feel free to be there, but more presence on LinkedIn, and we hope to see you over there. As usual, this material was not prepared solely by me, but was prepared through two instrumental PDFs. The one being what you are seeing here, and the second one is what we have here. And that is what was used in building this content for you today. See you in series 3 with the hands-on edition.